Okay, can you see the screen?
Yes, ma'am.
Okay, let's start. So here we will be starting the concept of continuity and differentiability. Here we will first we will be discussing the concept of continuity, and then we will move to differentiability. In differentiability, you have already learned this like differentiation and everything. It just started in the previous class only. Here we will be discussing the concept of chain rule and implicit function, how to do the derivative of that. We will be talking about that. Let's start with the concept of continuity. Just a moment. Okay, so when we are talking about continuity, here the name, if we will focus on the name continuity, that means in daily life also we just use this word. Just a moment. Okay, so this word continuity in our daily life also we use this word continuously. I'm working on something, or continuously anyone, a person is going to gym on daily basis. So continuity means like every day, or repeating the same thing. So here, if you will see the graph, if we are having the graph like this, okay, and here is a point, let's say x is equals to c. So we can, or this is one of the graph where we can see the graph is continuous at the point x equals to c. Whereas if we are having this graph where we are having like this, and then it is going like this, okay, and here is a point x equals to c, then we can see this graph, the second one, the first one is continuous at the point x equals to c. However, the second one is not continuous at the point x equals to c. So just by looking at the graph easily, we will be able to say whether the graph is continuous at a certain point or not. Okay, here we are having in previous class only you must have learned few functions like polynomial functions. There you have seen the polynomial function, greatest integer function, and signum function. So let's take one by one each and every function, because from here also the questions can come in the exam. And then we will be moving to the concept of like continuity, where we will be using limit and everything to check whether the given function is continuous or not by using the concept of limits. Okay, so first thing first, polynomial function. So in previous class, you must have seen polynomial we used to represent by px, fx, qx, and we used to write polynomial as a0 plus a1x plus a2x square plus a3x cubed plus a4 x to the power 4 plus a5 x to the power 5, where this a0, a1, a2, these are nothing but just the constants, and the power of x is continuously, it is just increasing. This is how we are having one polynomial function. Now if we will be having px is equals to a0 only. This is the constant function, which we also represent as a f of x is equals to c. Okay, like this we represent this constant function. Here a0 is nothing but just a constant. Or if we will take polynomial as a0 plus a1x, so this one is a linear function or linear polynomial, which we represent as a ax plus b also. So this is linear function or linear polynomial, you can say. If we will take as a px is equals to a0 plus a1x plus a2x square, only these three terms, if we will take up to x square, here the degree of this polynomial is x square. So this is called quadratic polynomial or quadratic function. We also just a moment. So we also take it as a quadrat. We also call it as a quadratic function, where we take ax square plus bx plus c, like this. Or if we will take px is equals to a0 plus a1x plus a2x square plus a3x cube, like that, then we call it a cubic function. Now we know that polynomial function is continuous for all x belongs to R. So let me draw the graph. When we are talking about linear function, something like y is equals to mx plus c, then we know the graph of such linear function looks like this. Okay, the straight line can pass uh, from anywhere according to the points given, according to the slope given, according to the y-intercept and everything. So this is, here you can see this is continuous graph. Okay, or if I am talking about the other function, that is what we have taken, the constant function. So f of x is equals to c we have taken, or y is equals to c, the constant function. Here the graph of a constant function will look like this. This is x-axis, this is y-axis, and it will pass like that. And here, wait, yeah, y value, suppose y value is a constant number. It can be 2, it can be 3, it can be 4. So this is how our graph will look like. And here also you can see it's a continuous function. Okay, or if we are talking about quadratic function, so one of the example of quadratic we can take as a equation of parabola. Y square is equals to 4x or something like that. So you know that equation, or x square 4y, if we take the equation of parabola. So one of the example, one of the parabola, if we will draw, it looks like this. You can see it's a continuous function, continuously, this graph is continuous, and hence we can say polynomial function is a continuous function. Yeah, and that is continuous for all x belongs to real number. Okay, or if we will take cubic function, even if we will take cubic function, so the graph of cubic function, if you will recall, which we have discussed in the previous class, it just looks like this. Y is equals to x cube, if we will take, this is how the graph will look like. Okay, so that's why we say that polynomial function is a continuous function, and it is continuous for all x belongs to R. Okay, now the next function we are having is, uh, let me check, f of x is equals to rational function. Okay, Rational function, rational number means p by q form. So rational function is also like that. We will be having px over here, we will be having qx over here, where px and qx are nothing but just a polynomial, where the denominator must not be 0. Okay, qx must not be 0. So this rational function is also a continuous function. It is continuous for all x belongs to r except the point where the denominator will be 0. So if I will take one example, that is f of x is equals to x by let's say x minus 5. So here you can see the denominator will be 0 at x equals to 5. So this function is continuous function. It is continuous for all x belongs to r, minus this 5, x value 5 is not acceptable over it. Okay, because it is making our a denominator 0 and the function will not be defined at that point. Okay, so we have to exclude that point. That's what now we are having modulus function. So modulus function we know. Let's check the continuity of modulus function. So we know modulus function defined as f of x is equals to mod x. We take it as a, when x is greater than 0, then we take mod x as a only x. When x is lesser than 0, then we take mod x as a minus x. Okay, you can understand that if we are having modulus of x, then inside the modulus whatever is there, 5 will be there, the result will be 5. If there will be negative 5, the result will be 5. So that's why whenever we are having a negative number which is lesser than 0, whenever we are having a number inside the modulus which is smaller than 0, one more minus sign automatically comes out. That is, it just comes as a minus of minus 5, and hence and then and only then it becomes positive 5. Okay, this is how modulus function works. Now the graph of modulus function you have already seen, you must have seen in the previous class only. So it looks like this, right? This graph, is it continuous or not? Anyone? Is it continuous or not? Modulus function is continuous or not continuous?
Continuous.
It is continuous. Okay, we can see in the graph itself. This graph is continuous. Okay, so here also we can say modulus function is continuous for all x belongs to real number. Greatest integer function or the step function. Why we call it a step function? Because the graph looks like the steps. Okay, so we know whenever we are having any number like greatest integer function x, here the value of x can be anything. Okay, so if we are having 2.5, what will be the result? Anyone? Anyone?
2.5.
Yeah, what?
2.5.
The result, like it will come out as a 2.5 only.
Yes.
Yes, everyone agreeing with him.
Yes,
Only
ma'am.
2 will come out. Okay, 2 will come out. How we take this greatest integer function? Suppose we are having 2.5. So let's take number line. Okay, here we are having a number line 0, 1, 2, 3, 4, like that. Here negative 1, negative 2, negative 3, negative 4, negative 5. Whenever we are talking about greatest integer function, that is, if any number is sitting inside this rectangular bracket, that means it's showing greatest integer function. However, it must be written in the question also that it is representing greatest integer function, or the other name is step function. Here whenever we will be having any number, let's take the above number 2.5. That means we have to take out the integer value which is smaller than or equals to this 2.5. We have to take out integer smaller than or equal to the given number. We must take out integer, and if you understand what exactly is integer, integers are the number 0, positive 1, positive 2, positive 3, positive 4, minus 1, minus 2, minus 3, minus 4. These are the numbers which are integer. So whenever we are having any decimal number inside it, we have to take out integer only. Okay, this greatest integer function, the name is greatest integer, so it will always give the result as an integer. Which integer? So smaller than or equals to, whatever is smaller or equal, nearest is smaller or equal integer, it will give as a result. So you can see 2.5 is lying over here. Okay, so when we are having 2.5 like this, it will give the integer value which is smaller than 2.5 and is nearest to 2.5. So smaller than 2.5 is 2, and that is nearest. 2.5 is lying between 2 and 3, so either our answer will be 2 or 3. But again I am repeating, it will always give the answer is smaller than or equals to. Why I am saying equals to? If you are having 5, so it will give 5 only. If you are having 2, it will give 2 only. Okay, so this greatest integer function will always give the result is smaller than or equals to what, according to the number which is there inside it. So 2.5, the just smaller than 2.5, we are having 2 which is smaller than 2.5, and yes, 2 is a integer. Okay, 2 is an integer, so the result will be 2. What about minus 2.5? Anyone? What will be the answer? Exactly. It will be minus 3. Okay. When we are having minus 2.5, the result will be minus 3. Again, I would say it will give smaller than or equals to the number which we are having over here. So 2.5, if you will see on the number line, is lying over here. Minus 2.5 is here. Is smaller than minus 2.5. If you will again take minus 2 as a result, then minus 2 is bigger than minus 2.5. Okay, when we are having two negative number, minus 2.5 and 2, minus 2, we know that minus 2 is greater than minus 2.5. If we are having minus 3 and minus 5, we know that minus 3 is bigger than minus 5. Okay, so it will always give a, like, very next integer it will give the result, but that integer must be smaller than it. So smaller integer than minus 2.5 is minus 3, not minus 2. That's why the result is minus 3 over here. Okay, now the graph of a step function is, it looks like this. I believe this one is clear to everyone. The graph of, if we are having 1 over here, if we are having 2 over here, if we are having 3 over here and 4 over here, then you can see the graph in between 0 to 1, whatever we will take inside it. If we will be having, let's say, 0.5, so the result will be 0. If we will be having 0.67, the result will be 0, because again I will repeat, is smaller than the nearest integer which is smaller than or equals to 0.5. So smaller than 0.5 is 0. The nearest integer, just a second. Okay, so we were discussing about the graph of this greatest integer function. So you can see 0 0.5, 0 0.67, even 0 0.9. This will give result as a 0 only. 0 0.99, this will also give result as a 0 only. Okay, and what about any number after 1? So if you will be having 1.5, the result will be 1. If you will be having 1.8, the result will be 1. Okay, so that's why the graph of greatest integer function looks like this one, from here to here. Okay, then in between 2 to 3, the result will be 2 only, like this. In between 3 to 4, whatever number we'll be having, the result will be 3 only. So you can see it will look like a steps. Okay, when we will be having 1, the result will be 1 only. When we will be having 2, the result will be 2. So it will be just before 1. Okay, it will, or we can give, this is like in front of 1. Okay, don't get confused. Here we are having 1, here we are having 1. Okay, so this is the graph of greatest integer function, and you can see it is not continuous. Where it is not continuous, at the integral value, you can see wherever we are having integers 1, 2, then 3, then 4, on this integers, this graph is discontinuous, and at the remaining point it is continuous. So the greatest integer function is discontinuous at integers, and it is continuous for all other value. Okay, other than integers, whatever like number we are having, it is continuous over there, but discontinuous at integers only. Now the next function. So far, is it clear to everyone? Anyone having any doubt so far?
No, ma'am.
Let's move ahead. So now we are having signum function. Signum function f of x is defined as mod x by x for x not equals to 0, and when x is 0, the value is 0 only. Okay, which we can define again. We know that f of x, it can be written as if x is smaller than 0, if x is equals to 0, if x is bigger than 0. We know when x is smaller than 0, this modulus gives minus sign, right? By one more minus sign will just, it will be there with x. Then and only then we get as a positive result. Okay, whenever we are having a negative number, whenever we are having any number which is smaller than 0, modulus will give one more negative sign by itself, so that it will, both the negative sign minus minus will become positive, and at the end we will end up having positive number. Okay, so when x is smaller than 0, we'll be having minus x by x. This modulus, I am redefining it again. Okay, which will be minus 1. 0 at x equals to 0, the signum function already it is written. When x is 0, the result will be 0. When x is greater than 0, it will be x by x, that is 1. Okay, so the function is So the function is f of x is equals to minus 1 when x is smaller than 0, f of x is equals to 0 when x is 0, f of x is 1 when x is greater than 0. How exactly the graph will look like? So from here only, if you will look at the function carefully, you will be able to understand that when x is 0, the result is 0. Okay, when x is greater than 0, when x is greater than 0, towards the right, towards the right. Just a second. Okay, so we were discussing about signum function. So when here we can see when x is greater than 0 towards the right side of origin. When x is greater than 0, the output is 1 only. Y value will be 1. When you are taking x as a 2, y is 1. X as a 3, y is 1. X is a 4, y is 1. So whatever we are going to take x value which is greater than 0, y value will be 1 only. Hence the graph over here will be going like this. Okay, y is 1. That means I want to show over here when x is 1, x is 2, x is 3, x is 4, y value is continuously, you can see it's 1 only. Okay, now when x is smaller than 0, y value is -1. When x is smaller than 0, y value is -1. We can understand y value -1 means downside. And when x is smaller than 0, when x is -1, when x is -2, when x is -3, when x is -4, continuously y value is -1. Okay. Now when x is 0, y is also 0. So here at 0, it is, here we have to keep open circle, because at 0, like this line is not touching the graph. Okay, at 0 this is not. When x is 0, y is 0. Okay, the origin is over here. This is the graph of the signum function. Now can you tell me whether it is continuous graph or discontinuous graph, and discontinuous at which point? If it is continuous, then also you have to define continuous for all x belongs to R or what. And if it is discontinuous, then what is the exactly point where it is discontinuous? Anyone? Exactly, it is, as we can see here, it is discontinuous at x equals to 0. Okay, now let's move ahead. Okay, so we have already discussed the concept of polynomial function, modulus function, rational function, greatest integer function, signum function. Now we will be talking about exponential functions. So when we are having f of x is equals to a to the power x, this is the exponential function we are having, where a must be greater than 0. Here we can take any x value. Okay, so for exponential function we can say x can be any real number. Let me show you the graph. From this function also you can see x can be any number, because it's the power can be positive, power can be negative, everything is acceptable. So the graph of exponential function looks like this. Okay, here it touches at 1. Okay, so, or we can say, if we will take the natural log, it, it will be natural exponent, so it will be e to the power x, where we can understand that when x is 0, when here also you can understand, when we will be taking a to the power 0, the result will be 1. Okay, that's why it is touching the y-axis at 1. When x is 0 over here, y is 1. This is the graph of exponential function, and here also you can see it is continuous. So we can say exponential function is continuous for all x belongs to R. It is continuous at all real number. Okay. Now we are having logarithmic function, which is f of x is equals to log x base e. And the graph of logarithmic function is here. We are having it is touching x-axis at 1. Okay, so this is the graph of logarithmic function. Now anyone from here, can you tell me, is it continuous everywhere or not? Anyone? Is it continuous everywhere or not? Yes. Is it continuous everywhere? Suppose we are having this, let's say we are having log y is equals to log x base e. It is continuous everywhere. Okay, let's check. Okay, so we are having this logarithmic function like this, f of x. I am writing it as a y. Okay, so that we can just convert logarithmic to exponential form. So as we know, there is a property of logarithm which says that, just a moment. Are we will it be possible to deduce from here? Just a moment. Okay, so if we will, yes, from here also we will be able to understand. Otherwise, I'll be taking one example. So if we will convert it to exponential form, can I write e to the power y is equals to x? Can I? Can I write it like this? We are just changing logarithmic to exponential form. Yes, yes. Exponential form is continuous everywhere. But we are talking about logarithmic function. We will get back to exponential function again. Okay, if there is any doubt over here. Logarithmic function, whether it is continuous everywhere or not, that we have not still figured it out. Okay, so this is the logarithmic function. I have written it like this. We can write it by using the concept of like property of logarithm. Okay, now here, if we are saying x value, if we are saying x value can be any real number. Okay, in the function only, if you are saying x value can be any real number, it can be -1, it can be -2, it can be 0.5, it can be 0.2, it can be +1, it can be +2, it can be +3. That means decimal, negative, positive, everything, all the real numbers are acceptable for x. Let's check. So is it possible that e to the power anything will give you a negative result? Is it possible? You will take e to the power 2, will it give you a negative result? If you will take e to the power -2, will it give you a negative result anytime? Is it possible? No. But whatever we will take as a power, even if we are taking the power as a negative number, that will go in the denominator. Just give me a second. No, really sorry. So I was saying that whatever we will take as a power of e, even if you are taking -1, -2, you understand that when the power is negative, it just the term goes in the denominator. We can make the power positive. Eventually, the answer we will get as a positive answer only. Okay. So x value never ever we will get as a negative. X means what? Again, I will repeat. X means the result. Once I have changed our logarithmic function into exponent form like this by using the property, here only we can understand that the result e to the power anything will never give a negative answer. Okay. So from here we can say that it will never, x will never ever be negative. It will always be positive. Okay. Are you getting it? And from here only you can understand that we are having e to the power y is equals to x. We have converted our logarithmic function log x base e is equals to y. This one we have converted into this one, and from here we are saying that the result x will never be negative. Okay, from here we can also see that when the result will be 1, when the power of power of e will be 0. Okay, that's why we are saying that the graph will touch x-axis at 1 comma 0, and it is continuous for positive real number. Okay, it is continuous for all x belongs to R positive. It will be, x value has to be positive only, no negative number. That's why whenever we are having log of any negative number, we say that it is not defined. It is not acceptable. Okay. Now let's get back to exponential function. Here, logarithmic function is only continuous for all x belongs to R positive. That means for all positive real number. What about exponential function? I said that exponential function is continuous everywhere for all x belongs to R. You can check. Exponential function means f of x is equals to a to the power x. Now the power can be anything. Power can be 0, power can be positive, power can be negative, power can be decimal, power can be fraction. Okay. So x can be anything over here. Everything is acceptable, and hence it is continuous everywhere. Okay. Is it clear so far? Okay, let's move ahead. Now, the algebra of continuity says that f of x, if f of x is continuous at a certain point and gx is another function that is also continuous at the same point, then we can say that f of x plus g of x will be continuous at x equals to c. Similarly, f of x minus g of x will be continuous at x equals to c. Similarly, f of x into g of x will be continuous at x equals to c. Similarly, f of x by g of x will be continuous at x equals to c. And if you will multiply with any scalar k of f of x or k of g of x, that will also be continuous for at x equals to c. Okay. So this property we can use this property. Suppose we are having one of the example that suppose at x equals to 10, mod of x minus 2 is continuous. Yes, it is continuous. We have discussed that modulus function is continuous everywhere. So at x equals to 10, it is continuous, obviously. And we have also discussed, just give me a second. And we have also discussed that, still we have not discussed, we need to discuss the trigonometry function. Suppose we are having sine of 3x. Okay, so at x equals to 10, this is also continuous, we know. So we can say that this modulus of x minus 2, or we can say 3 times modulus of x minus 2, will also be continuous at x equals to 10, plus 5 times sine 3x will also be continuous, and the sum of both this all together will be continuous at x equals to 10. Okay, so what we are doing, we are just using the property. At first we know that this is continuous at x equals to 10, and this is continuous at x equals to 10. Hence this all together, added together, will be continuous at x equals to 10. Here you can see I have multiplied with 3 over here, 5 over there. So we are just multiplying with the scalar, which is the last property, which says that even if we will multiply with the scalar, still it will be continuous at the given point. Now the continuity of trigonometric functions that we have not discussed. So we know that sine function, the graph of sine function, if you have seen that it's sinusoidal graph we are having. So it is continuous at all x belongs to y. Okay, x value can be anything. Okay, now the cos function, that is also continuous. We have seen in the graph itself that cosine function is also continuous for all x belongs to r. What about tan function? What about cot function? What about the other functions? So tan means sine by cos. Sine is continuous everywhere. Cos is continuous everywhere. So tan will also be continuous everywhere except wherever the denominator is 0, because that time the function will not be defined only. Okay, so we have to exclude that point. So it will be continuous everywhere for all x belongs to r except wherever the cos is 0. Where the cos is 0, odd multiple of pi by 2. Okay, so tan function is continuous, will be continuous for all x belongs to real number, but we have to exclude those points where the cosine function is 0. Now what about sec function? Sec function means 1 by cos. Cos is continuous everywhere, but this sec will also be continuous for all real number except the point where this cos is 0. So again odd multiple of pi by 2. Now cosec function, 1 by sine. Here it cosec will also be continuous for all x belongs to r except wherever the sign is 0. Sine is 0 at and pi, we know that 1 pi, pi 2 pi 3 pi 4 pi. So integral multiple of pi, that are the points where the sign is 0. We have to exclude that point. Okay, what about the cot function? Cot means cos by sine, and we know sine is, wherever the sign is 0, that we have to exclude. Then the function will be continuous for the remaining values. So that means x belongs to r minus again n pi. So these are all the trigonometric function I have taken over here. Let's move to the next part. Okay, now the definition, there is a concept which says that we can check the continuity of any function. A function is said to be continuous if limit x tends to, let's say c is a certain point f of x, left hand limit is equals to right hand limit is equals to function at at the given point. If this all three are same, then we can say the function is continuous at x equals to c. Okay, so and if this is not like all the values are not same, then we can say the function is not continuous at x equals to c. Let's do few question related to it. Let me take one question. So the first question says, find all points of discontinuity of f where f is defined as follows. So f of x is defined as modulus of x plus 3 when x is smaller than or equals to minus 3, minus 2x when x is greater than minus 3 and less than 3, 6x plus 2 when x is greater than or equals to 3. Okay, we have to check the point of like where the function is discontinuous and where the function is continuous. Okay, now if we will focus over here, like modulus of x plus 3 when x is smaller than negative 3. Okay, x is here, suppose we are having negative 3, 0, minus 1, minus 2, minus 3. So x is smaller than or equals to negative 3. So if we will take the function for this case, can you tell me what can be taken? This modulus, if we will take out x from the modulus sign, will it be positive x or negative x? Yes, sure, I can scroll up. Yes. Here or the question? Question? Do you want to see the question or the condition or this one? Please let me know. Can I go down? Can I scroll it down? Okay. All right. So we are having this question and we are checking what are the point of discontinuity. Now we can take this function. Yes, it will be negative. Okay, because we are saying that x is smaller than or equals to negative 3. X is a negative number. It is a small. Whenever we are talking about modulus function and when x is smaller than 0, it will give minus x as a result. Okay, when x is smaller than 0 means there is a negative number inside it. There is a negative number inside it and automatically one more minus sign the function will give to make it positive. And then and only then you always say from the very beginning, maybe from class 8, from class 9, modulus will give always positive value. Modulus will give always positive value. This is the reason, this is the logic behind that. Okay, so we can write this function as f of x is equals to it will be minus x plus 3 when x is smaller than or equals to minus 3, and when x is lying in between minus 3 to 3 it is minus 2x. When x is greater or equals to 3 it is 6x plus 2. Okay, we have to check the point of discontinuity. Now if you will focus on the functions, all the three cases, this is a polynomial, this is a polynomial, linear polynomial, this is also a polynomial. We know polynomial is continuous everywhere. Okay, so according to the point given we have to check these points are the point of continuity or the point of discontinuity. Let's check. Here I can see points are -3 and 3. I will locate it over here. 0. Here we must be having -3. Here we must be having 3. Okay. Now we will be finding left hand limit, we will be finding right hand limit, and we will be finding the function value at a given point. So if we will focus on one point at a time, that is -3. Now left hand limit of -3. So limit x tends to -3 minus. Okay. So smaller than equals to -3, that means we have to take this function. If you have to find f of x over here, that means you must take this function x tends to -3 minus, that is, this will be minus x plus 3. If we will substitute -3 over here, our result will be 6, right? Right? Yes. Let's take the right hand limit. So limit x tends to -3 plus. Okay. So that means greater or equal, greater than -3. Here the function where the x value is greater than -3, that is -2x. Let's take it. If we will write f of x over here, we must take limit x tends to -3 plus f of x is -2x over here. That will give, here if we will substitute -3, we will be having 6 over here. 6. We have got left hand limit of -3 as a 6, right hand limit of -3 as a 6. Now what about the value of a function at -3? Okay, so here you can see, when we have to check the value of the function at -3, we must be taking the first function. There only equality sign is there, so we must use that function, minus x plus 3. If we will substitute -3 over here, it will be 6. So left hand limit, right hand limit, function at the given point, all are same. So we can say the function is continuous at -3. Okay, so we can say limit x tends to -3 minus is equals to limit f of x is equals to limit x tends to -3 plus f of x is equals to f of -3. Okay. Now let's check at 3 because these 2 points are mentioned over here. So at 3 we will be checking. So when we will take limit x tends to 3 minus left hand limit of 3, f of x is equals to, let's see which function we will be taking over here. So we are talking about less than 3. When we will talk about less than 3, can you see x is less than 3? Whenever we are having x less than 3, we must take -2x. Let's take it. -2x, that will give just 3. We have to substitute over here. We are talking about +3. That means the result will be -6. What about limit x tends to 3 plus? Okay. So here we are having 3 plus greater than 3. That means 6x plus 2 we will be taking. F of x is equals to, please find it and tell me whether it is continuous for x equals to 3 or not. Okay. Check it and let me know. This is the given function. Everyone please do it and write your answer in the chat box. Have you checked at right hand limit, left hand limit of 3? Is it continuous at 3 or not? We will be taking 6x plus 2 over here. 6x plus 2. That means 6 3 times 18 plus 2 20. Now only we can say it is not continuous, because left hand limit is not equals to right hand limit. Now even if we will find the value of the function at 3, no need to do that. Here only we can say the function is discontinuous at x equals to 3. Is it clear to everyone? Is it clear? Okay, so I'm keeping it